Yeah. So we just select this and do the run. See what we got, the p-value is here. The p-value is 0.01135. That is less than 0.05. So yes, our question is correct. Does cows yield the cows yield is more than local check because the p-value is less than 0.05, then we can say that the yield of the cows is more than local check. If it's the p-value here is if it is more than 0.05, then we cannot say that the cow's yield is more than local check. Again, if you want to check for the F test we check for the variance versus variance, and we change the data here into wheat. Yeah. So again, we are checking whether the super cows and the local check across different countries is same or different. The comparing the yield variability between two genotypes. Again, the F test formula is variance dot test. That's a VRR dot TST. So this is the data, genotype, country, and the yield. We are checking super cows, and local check. This is the super cows. This is the super cows and local check. The super cows and local check across different countries, the yields are same or different. We are checking by F test. Select everything and just run it. So again, the p-value is 0.6421. It is greater than 0.05. So we cannot say that the super cows and the local check yields are different, significantly different. No, they are not because the p-value is greater than 0.05. So even if you like, if you want to see, if you just want to have a summary of any data, suppose you got the wheat data and you want to see the summary, what is the mean, what is the minimum, what is the maximum, what's the median. There is a code in R. You just write summary. You get the summary, and you just write the data name. Wheat is our data name, and you put the dollar. The dollar is for selecting the variable. You press the dollar there and you get the variable to select. So our variable is yield because yield is the only thing which is numerical. Select yield and just run it. So you can get the minimum is 0.429. The first quartile is 2.93. The median is 4.143. The mean is 4.341. The third quartile is 5.732. The maximum is 9.683. So you get all the values required for the box plot. You get all the values required for the box plot. The first quartile, the median, and the mean, the third quartile, and the max. This is called whisker plot. So you can able to see the whisker plots by just putting the summary statistics here, and you can able no need to calculate separately. The third one is correlation. The next one is the correlation. So correlation is very important. For the correlation, I have made separate data. So you need to go to import data set from Excel, browse, wheat data, open it. There are two different sheets. If you go to the sheet default, there's a this one, there's a sheet one. Just click to the sheet one and it will come different data set here. So you make all the double into numericals. Numeric, 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 numeric. Because this data is in numeric format, so we need to make everything into numeric. So gives them separate name for this data. Suppose you can give as correlation, CORL, CORRL, and just import it. Just import. So we have a two data set. One is wheat and one is correlation. So correlation has what's the data set tells here. So each country, what is the performance of Bacanora, what is the performance of Bagula, what is the performance of Compass 888 cows. So each variety's performance across different countries, Argentina, Bangladesh, Bolivia, Mexico, like this. So each variety's performance across different countries. We want to see whether each variety is correlated with other variety. Suppose performance of the yield of Bacanora is correlated with performance of the yield of Bagula or not. If the yield of Bacanora is increasing across different countries, then the Bagola yield is also increasing or not. Then the Bacanora's yield is increasing, the Compass yield is increasing or not. This is called correlation analysis. So we want to see the correlation between these two, this different all over the possible combination of these all genotypes across different countries. So for that, you need to there is a very nice package. You can also do the stability analysis in this package. I have already installed that package in my R Studio. For just showing to you, you can just go install dot packages. Then is covered with this kind of symbols. Then Metan. The package name is Metan. So install dot packages. Then two apostrophes here. Two apostrophes here. The package name is Metan. Just run it. So it takes some time because I already installed the Metam package, so it's already installed in my R Studio. So after installing R package, you need to open that package. To open that package for the calculations. To open that package, we just do library close Metam. Control enter. The package is open now. So just remove this. So this is the formula. This is the code. So this is the code for correlation analysis. You get the all correlation plot and the significant values, p values, and everything. So this is the CRR, the correlation plot, the correlation coefficient, and this should be the data name. Our data name is CORRL. This is our the data set name, and it can take all the numerical value by itself. You can give the color. The low correlation should be in white, the high correlation should be in the green. Just select everything and run it. So go to the plots here on the right hand side, go to the plots here and just zoom it. There's a zoom and you got the correlation. Very nice correlation plot. What you can see it here. So there is stars here. The two star means the level of significance is at p is less than 0.01. That's a 1% level of significance. And the three star is 0.0001. That's a 0.1% level of significance. And the one which is no significance is the value is greater than 0.05. So everything is statistically significant. So how to read this plot? Because Tevia and Bacanora, this is one. You need to go one horizontally, one vertically. So Bacanora into Tevia is a 0.71 correlation. So Tevia yield is increasing, then Bacanora is also increasing in the proportion of 0.71. And Bagula and Tevia, this is Tevia and this is Bagula, 0.68. The both yields are increasing. So you can find any one which is high correlation. So 0.91 is the highest correlation 1 year. There is a 0.94 year. So 0.94 what it tells, the local check is between local check and Compass T88 variety. So these two varieties are performing like similar. If there is a 1 kg increase in local check, there is also around 1 kg, more or less 1 kg increase in or 0.94 increase in Compass T88. So there is a strong correlation here. So we do have a correlation here called Maturi and super cows. So this is the correlation matrix. This correlation matrix is easily acceptable in any publication journals. because this has all the significance levels, all the correlation, and is easy to read, and you can able to find out the correlation about any kind of variables using this metan package. So this is what for today, and let me know if you have any questions or anything. If you don't able to understand, you can just ask any questions to me. So we are left with another 15 to 20 minutes. I think 15 minutes. So if you have any questions in the R studio, or if you have any questions in statistics related to present topic, you can ask me.
Hello.
Yeah, Nikita.
Sir, actually, the plot is not visible to us properly. It is compacted. So, can you show the proper plot?
Plot is not visible to you. The my plot.
It is visible in your R studio
Yeah,
in the environment section, but
yeah.
the zoomed version is not visible to us.
1 minute. Just a minute.
Okay.
The zoomed version.
I think you can save it, export it, and show it as in your
Yeah,
gallery
yeah,
or
yeah.
something.
Just a minute. Can you able to see now?
Yes, sir.
Yeah,
Perfect.
this is the zoomed version. So I was explaining in this version till now. So this is the what the plot looks like, and the star values here indicates the level of significance. If it is one star, the level of significance is 0.05. If it is a two star, the level of significance is 0.01. If it is a three star, the level of significance is 0.001. So it has calculated all the possibilities of level of significance. And if there is no star, the level of significance is greater than 0.05. That's there is no proper correlation. So whatever the correlation we got here is statistically significant because it has the level of significance greater than 2. And you can see here how the correlation plot needs to be read. So the local check here has a correlation of 0.94 with the compass T88 correlation. Suppose the local check yield is increasing by 1 kg, there is also increase in 0.94 kg of compost yield. So these both are behaving, the yield performance of both these two varieties are behaving similar to each other. And you can see like some similarity, the super cows 0.91 with compass T88. The correlation between super cows and compass T88 is 0.91. The correlation between Maturi and cows is 0.9. The correlation between Maturi and compass T88. Compass T88 comes here, Maturi comes here, is 0.94. So this is how the plots is read, and this is how the level of significance of each correlation is showed here.